guys, welcome to my channel. I'm LeetCode. If you guys are new here, I pretty much do LeetCode style questions and I explain things in the simplest way possible. Today we have a pretty interesting problem that I'm very excited about, so let's go ahead and read the problem statement. So it says the problem is called binary search tree iterator, right? So it says implement the BST iterator class that represents an iterator over the in-order traversal of a binary search tree, right? Very important, right? Says this BST iterator, right, is this constructor, right, is going to be initialize an object of the BST iterator class, right? The root of the BST is given as part of the constructor, right? Yeah, we're going to be given a root, right? It says the pointer, right, should be initialized to a non-existent number smaller than any element in the BST, right? Cool. And it says this function as next, right? It's going to return true if there exists a number, right? And the traversal to the right of the pointer, right? Otherwise return false, right? And he says int next, right? Returns, moves the pointer to the right, and then returns the number at the pointer, right? Okay. Pretty much, guys, we have three things, right? You know, we got the constructor, right? It gets initialized. We're going to be given a root, right? A BST root, which is important, BST root, right? And then we need to initialize the iterator. The iterator that we're going to implement, right? We're gonna need to implement that, and then there's a has next function, right? No, pretty much let us know there's still nodes, right, in the iterator, right, to be processed, and then when you call it next, right, pretty much gonna return the next value, right? So which is integer, right? So they kind of yeah, guys. So pretty much you guys can see from this thing that we're given, right? It gets initialized, right? So pretty much this is the input, right? Pretty much BST, right? Iterator, right? Pretty much that's what gets initialized with that BST, right? And then we call next, right? We call next, which returns the smallest number, since that's the first one, right? So returns next, returns 3, right? Next again, right? Returns 7, which is right. And then returns, it checks as next, right? Yes, there's still nodes in there, right? And then we keep doing different calls, guys. So pretty much, guys, you can see that they mentioned that they want an iterator to be the in-order traversal of the binary search tree, guys. So yeah, so that's how we're going to implement the iterator pretty much, right? Pretty much we're going to do the in-order traversal of the binary search tree, right? As expected, right? That's what we're going to do, and that's how we're going to pretty much do the whole process, right? So yeah, guys, so right now we could easily do pretty much have some kind of list, right, like an array list, visit the node, right, and then do the in-order traversal, right, recursively, right, and pretty much keep track of an index, right, and then pretty much add all the nodes, right, so since doing the in-order traversal of the tree, of the binary search tree, right, it's going to give us the nodes in non-decreasing order, guys. So very, very important, right? So pretty much if we do the in order, it's going to be 3, 7, 9, 15, 20, right? So we can have that in the list, right? And then have an index for pointer, right? That can help us in keeping track of where we are, right? And then we could do it like that, right? I'm saying recursively, you know, but we could do a little bit better, guys. So the way that I'm gonna go about solving this problem, guys, is gonna be kind of the same way, guys. You know, I know when we normally do the recursive problem, I mean tree problems, right, we normally do it recursively, guys, you know, using the call stack, right, to visit the nodes and process the node, right? We never really do it iteratively by using an actual stack, right? Yeah, so it's kind of good to know how to do it both ways, guys. So right now, that's exactly what we're going to use, guys. We're going to use an actual stack, guys, to kind of pretty much do simulate having in the recursive stack, right? The recursive calls, right? So pretty much simulating doing it recursively, pretty much, right? But we're going to be using actual stack, right? Pretty much that's going to really help us in solving this problem, right? So pretty much we're going to have a stack, guys, as a property of the class, right? As an instance variable. That's pretty much going to help us and in keeping track of the node, visit the nodes in the way that we want, right? Like a stack, pretty much, right? So pretty much we're gonna visit the left side. Pretty much we're gonna do the in-order traversal, right? Visit the left side first, right? And then visit the root, right? And then visit the right side, guys. So that's the same order of how we're gonna go about solving this problem, guys. So the stack, right? We're gonna pretty much we're given the root, right? We left as much as possible first, right? Pretty much we add 7 to the stack, we add 3 to the stack, right? And then now we're done, right? So there are no nodes on the left hand side, right? And then now when they call bst.next, right, we return the smallest element, right, which is always at the top of the stack, guys. So that's why 3 is chilling at the top of the stack, right? And we call it, and then 3 passes these right side, right, this right subtree, what I'm saying, right child, to pretty much add it to it. So an A has no right child, so we don't worry about that. That's not a case, right? And then now we return x bst.next, right? The top of the stack now is 7 now, right? And then 7 gets popped off the stack, right? And then before we return it, right, we always pass in our right child for after, right? And then our right child, right, pretty much gonna go as left as possible, right? And then we do 15 gets added to the stack, right? Boom. 9 gets added to the stack, right? Now 9 is at the top of the stack. That's why when we call next on the next one, right, we're able to return 9, right? Yeah, that's kind of the whole thing, guys. So let's quickly implement that real quick. Hopefully you're able to follow my process, right? So pretty much, guys, like I said, we're gonna have some kind of instance variable, right? Stack, right? Pretty much it's gonna be a stack of tree nodes, right? Pretty much helping us in keeping track of the nodes, right? As we visit them, right? So pretty much we call it S, right? And then once the object gets initialized, right, we need to initialize the actual stack, right? Right, we create space for it, right? And then now, guys, we need to pretty much gonna be having this function, right? Pretty much a push function, pretty much, right, to help us push the node, right, toward the stack, right? Pretty much fill up the stack for us, right? And then so pretty much so the as next function, right, is pretty much gonna be easy, right? This API should be, so pretty much if the stack is not empty, right? So if the stack's not empty, right, I mean there's still more numbers, still more nodes, right, in the BST that we can send to the caller, right? So that's what this function does, right? If the stack's not empty, right, then it has next, right? And then so let's implement the push function, right? So the push function is going to be pretty intuitive, right? So pretty much we void, right, helper, push, right? And then remember we were given this we're gonna be passing in the root, right? And then I told you guys we always go left as much as possible, right? So while the root, right, is not null, well, the root is not null, right, we're pretty much gonna be inside of this while loop, right? So pretty much what we do, guys, we do that push, we push the root, right? And then we root is equal to root that left, right? We go as left as much as possible, right? Boom, 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 right? Every time, right? And after we do that, right, so we visit the left side first as much as possible, right? And then we push everything to the root, to the stack, right? So pretty much for the first case, right, we 7, right? 7 is the root, right? So we initialize it with the root, right? We pass in the root, right? And then 7 gets added to the stack, right? Boom. 3 gets added to the stack, then boom, right? So now the 3 is at the top of the stack, and then we could have access to it, right? When they call this function, right? Its job is pretty much to tree node, right? So node pretty much gonna be as that pop, right? We pop it off the stack, right? So we have access to that node now, which is 3, right? Because since we were adding, right? So 3, we get 3 out of the stack, right? And then now we need to do some things, right? We need to pass in our right child, right? So because remember, this is what the inner traversal is, right? We visit the left side first, right? You know what I'm saying, and then we process the node, process the root, right? This is why it simulates, right? Process the root, and then we pass in our right child, right? That's how it works, guys. So, and then now we do node that right, passing the right child, right? And then and then the right child is gonna go as left as possible, pretty much, right? Every time. So after that we return, guys, node that val, right? The value that's inside. That's what they're interested in, right? Which is integer, right? So it seems like we're pretty good, man. Let's press run code, see if we pass all some things. Of course, I'm missing this one. I'm always missing some stuff, right? I'm never perfect. All right, cool, guys. We got this. Yeah, so quick example, guys. So let me just make sure that you guys get this right. Pretty much that's the stack, pretty much, right? We add stuff to the stack, so pretty much we pass in the root, right? Root gets initialized, right? Passing 7, right? 7 goes as left as possible, right? So we add 7 to the stack, boom. We add 3 to the stack, boom, right? We go left as possible, right? Root is going to root that left, right? We get there, and then we call next, right? Next 3 is at the top of the stack, right? We pop off 3, right? And then we return, and then 3 passes its right child, but there's nothing, right? And then 7 call next again, right? We pass in 7, right? And then we return 7 to the caller, right? So we're doing that. Before we return 7, right? We get 7 up the stack, right? And then we pass in our right child, guys, what I'm saying, which is 15, right? So after we return 7, then we pass in 15, right? And then 15 gets added to the stack, right? See what's happening here. This is what's happening here, right? So the stack, right? And then we go as left as possible, and then we add 9 to the stack, right? Boom, right? And then just like that, guys, they keep doing the same thing over and over. So they call next again, right? 9 top of the stack, right? And then yeah, it has next. The stack is not empty, right? So we still have nodes in there, right? That's what's happening here, right? Still nodes in the data structure, right? So there's still next node, right? So yeah. So let's press submit. Sorry about that. I removed that. Press submit. Perfect, guys. We were able to pass all the test cases, guys. So I want to thank you guys for taking the time to watch the video. If you guys found value, make sure to give me a like. If you guys are new here, make sure to subscribe, because I'll be doing a lot of other videos just like this one. So thank you guys for watching, and I'll see you guys in the next one.